So in this session I will explain the program for fourth experiment. This is experiment number 4 and this is the program written in assembly language. I will explain this one and then after I will move on to explain machine language programming also. Okay, so this experiment number 4, that is addition of 8-bit number series neglecting the carry generated. Okay, so what we have to do here, we have to add numbers means which are present at different memory locations, and those numbers are in series. Just like if the first number is at uh, just like 3000, then the second number 3001, then 3002. So if these three numbers are present at these three consecutive memory locations, then how we can add. And when we add the numbers one by one, just like if I add first and second number, and if in that addition, in the result, if we get a carry, then we neglect the carry, and then we add the result of the first and second numbers addition to the third number. Okay, and if whatever result we get, if there it is carry, then that carry it is going to be neglected, and then that result can be added to the fourth number. Okay, so that for that kind of addition here we will do. So the first instruction here given LXI H2100. Okay, so what we have to do here at 2100, this instruction means, so we have to now LXIH, sorry, LXIH, it loads HL pair with 2100. It means, so what we will get here, HL pair we will get 2100. Okay, so whatever we have here, this HL pair, whatever we have in HL pair, so that it acts as the memory. So now it is M. Okay, now from now onwards, so whenever we refer memory M, so that it is this 2100. So next instruction we will move B comma M. So B comma M meaning moving or you can say transferring the data from memory to register B. So what we have in the experiment is the memory. So if we assume that if we have to add 4 numbers, then if we store at this memory address, at this address, if we have 4, what we have here 4, 0 4, 0 4 if we have at this address, so 0 4 it will go here, so we can say B will become equals 0 4. Okay, so we have 0 4 in B register. Then the next instruction given XRA is XOR operation with the accumulator to accumulator, because this A it is representing accumulator, and here XRA it is XOR operation with the accumulator. It means XOR operation, accumulator, XOR accumulator. So we already know in case of XOR operation, whenever the same bits, then we get output as 0. For example, so whatever we have in the accumulator, so if we assume that in the accumulator that is 0 1, so if we do XOR operation, just like XOR operation, and if it is 0 1, because this is also A and this one is also A, so 0 1 XOR 0 1, so what we will get 0 0. So XOR operation means if 0 0, then output you will get 0 1 1 means same, then output 0. It means what we will get in the result. So here by doing XOR operation, we are clearing the accumulator. So here we will get in the accumulator 0 0. Okay. Next instruction, that is INXH, that it is to increment HL pair. So when we increment HL pair, so here it was HL pair 2100. So when we increment that, so then here HL pair it will become 2101, and this HL pair it is nothing but M. Okay, because whatever we have in HL pair register, so that it acts as memory. So now M. So now memory became 2101. This location is going to act as memory. So from now onwards, so whenever we say memory, it means that is location 2101. Next instruction that is given, add M. Add M. So this instruction is to add the content of the memory with the content of the accumulator, neglecting the carry. It means carry it is not going to be here add. Means we in this instruction carry is ignored. So that's why here what we will get in M, this one it is 2101. If we assume here, so at 2100 we assume that is 4, and 2101, if we take this one here, just like 10, that is the first number, then 2102, if we take the second number, that is 02, and at 2103, if we take third number, so if we are assuming that it is third number, it is 08, and if it is 2104, and this if we are assuming that is 04. Okay. So add M. Add M meaning, so this one is M, so it means 10 plus 00, because accumulator it is 00, and this one it is 10. So 00 plus 10, you will get 10 in the accumulator. So this one it is in the accumulator. Okay, that is because by default the result it is going to save in the accumulator. Then the next instruction given, decrement B. Okay, so decrement B means decrement the content of the register B. So register we have 04, so here we will get B equals 03. Okay, because here was 04, when we decrement then we get 03. Next instruction given, JNZ 2005. This instruction is jump if not 0. So what it does, it checks the content of register B here right now, and then if it is not 0, then in that case it jumps to the address 2005. So since here register B content it is 03, it is not 0, it means it will go here, okay, at 2005. So when here it is 2005, then what will happen here, INXH means increment HL pair. So again incrementing means, now earlier it was 2101, now it will become 2102. Okay, so now then after 2102 memory, and then after next add M. So add M meaning, so 2102, that is the memory that it will add. So this content 02, it will add to this accumulator content, that is 10, and then after again next instruction that it will become, I will show you. So when increment, so from here JNZ means since it is not 0, it jumped here, so increment H, it means now it will become, now it becomes 2102. Okay. Next here it is memory, add M. Add M meaning whatever it is the accumulator, so content of the memory will be added to the content of the accumulator. So memory accumulator we have 10, so now here you will get 10 plus content of this 2102. 2102 we have 02. So now we will get, so this is in the accumulator. Okay. Then after next instruction, decrement B. DCRB means decrement B. It means now it will become 02, and now in JNZ means if B it is not 0, then jump to again 2005. So if again jumping, then HL pair INXH means increment the HL pair. So here incrementing HL pair, meaning here it will become 2103. Now from now onwards, if we refer memory, it means that is the memory address, or you can say memory location 2103. So here next instruction given add m. It means we have this add m. It adds the content of the memory to the content of the accumulator, and the result we will get in the accumulator only. So here earlier it was 1 2. So what will happen here? 1 2. It was the one. It is the content of the accumulator. Then after add m. So add 2103, whatever it is the content that we have to add. Okay. So when we add this, so here now you see 1 2 and 0 8. 8 into 8. So in hexadecimal we are ready now. So after 8 we have 9, and then after 9 we have A. So here we can write on A, and this one is 1. This one we will get okay. Lights gone, so no issue. I will explain. I think whatever written on the board, it is visible. Maybe I am not visible. Okay. Then here given when we add 1 2 and 0 8, then we get 1A. So that 1A we have here in the accumulator. Then the next instruction, that is in decrement DCRB. It means decrement B, meaning now if we decrement, then we will get 0 1. Again next instruction J and Z 2005 means jump if not 0. So since B here it is not 0, so it will again jump to 2005. Same process will repeat. So increment INSH, it means increment HL pair. So here you will get 2104. Then add m. So now m means 2104. So the previous value it is 1A. So here what we can do, we can add plus 180 the content of the accumulator, previous content, and then 2104, that is 04. Okay. Then after next instruction, when we add this, then we will get A, B, C, D, E. So here we will get 1E. Okay. This is the result. Then after next instruction, that is DCRB, it means decrement register B. So when we decrement, then we get 0 0 in register B. So here J and Z 2005, jump if not 0. Since it is 0, now we get 0 here. So that's why it will not jump to 2005, and the processor will execute the next instruction, that is STA 2100. So STA, that is store accumulator to the address 2100. So content of the accumulator we have 1E. Okay, so here, so this 1E it is going to be stored in 2100 address. Okay, so here you will get 1E. Content of this accumulator will come here. Okay, then the next instruction given here, RST5, that is restart 5, that is a kind of subroutine which sends the processor to the location 280028. Okay, that address it sends, which ultimately leads the processor to stop further processing the next instruction. Clear? I think this one it is clear.